Hello everyone, welcome back to week 4. In this video I'm going to give you an overview of what you are going to study in this week. Let's first recap what we have studied so far. The first 3 weeks we have studied the concept of truth tables and how we could implement a system that has a number of inputs and a single output. We have studied the concept of a product of sum and the sum of product that could be derived from these truth tables. And by the end of the day you can minimize these expressions that you have obtained from the truth table either algebraically or using K-maps. And you have seen that K-maps could be any number of variables. So if it's a 2-variable K-map or 3-variable K-map or 4-variable K-map, you could do the minimization of these expressions and find the expression that minimizes the function. Okay. However, these K-maps work well if the number of inputs to the system are fairly small, like 2, 3, or 4, or even 5. However, if the number of inputs were fairly large, then we do not expect that we could be able to solve these kind of K-maps. An example of this is a K-map of 10 variables, so a system having inputs A1 through A10. That's a fairly large number of inputs, and a K-map, we do not really know how to solve it if that number of inputs were very large. So in this week we're going to cover the concept of programmable devices, and example of this are the PAL, which is the PAL, the ROM, or the PLA. Okay? And by the end of this week you'll be able to know how to use these devices to implement the system with a fairly large number of inputs. Moreover, you'll be able to implement systems that have multiple outputs, which is not easy to be implemented using K-maps. K-maps solve systems with just one output. Okay? And at the end of this week you're going to study a system that has a little bit, you're going to study a topic that is a little bit slightly different than than the concept of programmable devices. This topic is called the 3-state devices. What are they? They are basically another state that is implemented that we do have in our circuits. We do not have just logic 0 and logic 1. There is another third state, which is high impedance state. In the last 2 lectures, which are called output configuration and applications to the 3-state buffers, these 2 lectures cover this topic and tells you how to implement it and what the application of these 3-state devices are. Okay, I'd like to point you out that these 2 lecture videos are self-contained. What do I mean by that? If you watch the video output configuration, it's the same as if you watch the video applications. Okay? Why? Both of them cover the same topic. However, output configuration video covers the topic of 3-state buffers from an implementation point of view. It tells you how we could implement these 3-state buffers in the circuit in the lab. Okay? However, the other video, which is applications, it tells you what we use these 3-state buffers in. What are the applications that use these 3-state buffers? Okay, so the first video, which is the output configuration, it is a little bit advanced. We do not expect that everybody understands everything in this video, so we will not include any of the questions of the exam to cover this particular video. However, the video of applications is going to be covered in the exam. Okay, and that's why I encourage you to watch both videos. However, to focus more on the second video, which is video applications. Okay. The last items are the quiz and the 2 labs, the sim labs in lab S2 and hardware lab H2. Each one of these 2 labs has a video. Please have a look at the video. It is not a step-by-step procedure video. It just gives you an understanding of what problems that you might face while doing the lab. So have a look at these videos before you answer the lab and before you ask any questions on the Piazza. However, if you still have questions, please post them on Piazza, and but make sure first to have a look at the FAQs of week 4. All right.